Um, Several years ago, Harvard Business School professor Clayton Christensen introduced the concept of disruptive technologies, technologies that when they first appear really don't seem very threatening. They're not nearly as good as what currently exists, except for the fact that they do things in somewhat different ways, and before you know it, they obliterate the old technology. One of my friends, Bill Wolf, who is a computer engineer and just stepped down as president of the National Academy of Engineering, contrasts the steam shovel with the backhoe. And I don't know how many of you are young enough to remember that usually when you used to see a construction site, you'd see a big piece of machinery with a shovel that would dig in and lift dirt out and dump it away. Well, folks figured out that in fact a backhoe, which digs it like that and lifts it up and moves it, is a cheaper way to get the job done. Wasn't apparent right away. But today you can't find any steam shovels or construction sites. They've been obliterated. Disruptive technologies generally evolve more rapidly than society can respond, and that's why they disrupt society. And they, from a strategic point of view, one should exercise great caution in procrastinating or simply freezing into inaction because denial and ignorance are the most dangerous courses of all during a time of rapid technological change. The final theme. Over the course of the last several years, a number of organizations, the National Academy of Sciences, the Council on Competitiveness, which is a group of CEOs and university presidents, other thought leaders, have begun to converge on the concept that the real core competency of the United States, what gives us the edge in the global economy, is not the size of our population or our natural resources, but it's our capacity to innovate. The characteristics of this country, the degree of freedom that we have, the fact that we're a nation of immigrants, continually turning over with new people and new ideas, new energy, stable laws governing things like patents and business. All of these things really create a very fertile environment for innovating. And the belief is that innovation, that is essentially creating, transforming knowledge into products, processes, and services of values to society, is the real key to our economic prosperity, our national security, our social well-being. The reason why the issue was raised is that many folks believe that we simply have not been investing recently in human capital, that's in education, or in new knowledge, that's R&D. And largely as a result of these concerns, about a year ago, President Bush announced what he called the American Competitiveness Initiative that will double R&D in this country in certain areas over the next decade and make significant investments in education. Congress one-upped him with what they call the American Competes Act, which was passed in late spring, which will actually accelerate that process if, in fact, they can get the appropriations out the door to achieve it. But, of course, anything that requires money is competing with the dollars flowing over into Iraq and Afghanistan. So that may determine how rapidly we kind of underscore innovation. So the 5 themes. The knowledge economy, globalization, demographics, disruptive technologies, and the importance of innovation. Now, those are the themes. Now, let me kind of move to 2 examples of how that affects things. I'm an engineer by background, in fact, an engineer and educator, and so the concerns that have been expressed over the last several years that this country is simply not generating enough scientists and engineers, particularly compared to countries like China and India, in which, at least so people claim, the production of engineers ranges from several 100,000 to perhaps 500,000 a year, raises great concern. In fact, in the United States, we've seen a decline of the number of students interested in engineering majors now for about a decade. That's turned around in recent years, but now it apparently in the last 3 years has leveled off and is beginning to drop again. It's particularly true at the graduate level, where 40% of graduate students in engineering are now foreign nationals, and that percentage is continuing to increase. To put it in context, the United States currently accounts for less than 8% of the new engineers educated in the world today. In fact, in the United States today, only 4% of college students major in engineering, compared to about 12% of college students in Europe and about 40% of college students in Asia, where the large populations are. Now, in the past, we've compensated for this by being a magnet for talented students as well as talented engineers and scientists from around the world. But in the wake of 9/11, the complexity of immigration policies influenced by concerns about homeland security, coupled with, quite frankly, an increasingly cynical attitude around the rest of the world toward American foreign policy, particularly because of the war in Iraq, and then finally the fact that many other nations now are building very strong educational complexes with the effort of attracting to their colleges, universities, and companies talent from around the world, is giving us more of a challenge in depending on international students. Do we have a shortage of scientists and engineers in this country? Well, that's an interesting question. Last week, in testimony before Congress, several labor economists suggested we do not. In their interviews of industry, industry felt that they could fill most jobs within a few months. They felt that they could get adequate support of science and engineering. But if you drill below those numbers, what you'll find is they're getting those engineering services offshore. The two buzzwords that characterize this particular field today are outsourcing and offshoring, all thrown together in what industry calls global sourcing. Industry today involves transnational companies that procure supplies, including human capital, wherever they can find it at highest quality and lowest cost. In the past, that applied, in the case of labor, to fairly low-level labor for manufacturing, assembly, and so forth. But with the explosion of engineers and scientists around the world, particularly in countries which have a rather established capability in education, India, for example, with its Indian Institutes of Technology, Eastern Europe with the strong background in science of countries like Hungary, Poland, Czechoslovakia, the former Soviet Union, what they're finding is that they can not only outsource engineering services, but they can actually offshore jobs. I'm a director for a company, Unisys, an information technology company. We, at one time, were one of the leaders in making big iron, that is mission-critical hardware. All of that activity has now been outsourced to Asia. And in fact, all of our software development, by and large, has now been offshored to Bangalore and to China, where we find very high talent, not simply in doing kind of commodity engineering things low level, but working up the value chain to do systems architecture, even at the highest level of competence, including R&D and innovation. So herein we have a certain challenge. Unfortunately, many companies today in this country, although they're transnational companies, have decided that American engineers are a bit too expensive. For every American engineer, they can find someone just as talented, just as well educated, willing to work just as hard, if not harder, for 20 cents on the dollar. Several months ago, the National Science Foundation had a conference in Washington called the 5X Conference. And the theme was that American engineers in a world of global sourcing, the global knowledge economy, will have to produce about 5 times the value added to compensate for the wage differentials between this country and other parts of the world where these companies can outsource activities. Now, the difficulty here, of course, is that if this is the philosophy that we have, allowing very short-term interests to dictate strategies which say, well, it's too expensive to hire American engineers or to invest in their education, we'll just offshore it, and to do that in other areas as well, such as R&D and so forth. Pretty soon we're going to look in the cupboard